Hello everyone. In our last session, we just started the inverse trigonometric functions and we have explained each and everything, especially for the related with the function parts. I gave you some values with the unit circle also. So now we are stepping to the next step, and for this special for this inverse trigonometric functions, we have to prove some properties for it. Okay, some basic properties and some little bit a new thing for you. So I have written on the blackboard, and this is property 1. It is property 1. Now property 1 we have to prove, or I can write it prove. Suppose we are having prove. Now we are having 6 results where sine inverse sine theta is equal to theta. We have to prove this sine inverse and sine theta is equal to theta, because this is much important and it is a lot of helpful for us for solving the entire questions. So sine inverse sine theta is equal to theta for all values of theta where theta belongs to minus pi by 2 and pi by 2, that is the principal value. Similarly, cos inverse cos theta is equal to theta for all values of theta where theta belongs to 0 comma pi. When I explained you in the unit circle, there it was very much clearly explained to you that how the principal value falls from minus pi by 2 to pi by 2 for sine theta and for cos theta from 0 to pi. Similarly, all the 6 were explained to you. Now tan inverse tan theta is equal to theta for all values of theta where theta belongs to minus pi by 2 and pi by 2. Similarly, for cosecant inverse cosecant theta is equal to theta for all values of theta where theta belongs to minus pi by 2 to pi by 2 and theta should not be 0 also. For the secant theta, secant inverse secant theta is equal to theta for all values of theta where theta belongs to 0 comma pi, and here theta should not be 90 degrees, should not be pi by 2. Lastly, for cot inverse cot theta is equal to theta, we have for all values of theta where theta belongs to closed interval 0 comma pi. Here open interval 0 comma pi, not closed, open. This is open and closed is this one the square intervals. Okay. So now based on these questions, this property, not questions, based on this property, let's first of all prove it, and then we are going to follow some questions related with this one, and very interesting questions. Now in the beginning of this chapter or in the last chapter also, in the relations and functions, what we did some functions that were the composite of the functions when we combined some functions. A function from a to b is function f, a function from a to b is function g, what was the relation with them. Similarly for the inverse part, now here we are having, now all of you are knowing, or we can write it, we know that, and what we means here, we means me and you. Okay, so we know that a function from a to b, it is, we did lot of questions in relation and function. A function from a to b is bijective then what it was when a function is 1 1 and on to, and very much clearly I explained you that how the trigonometric functions are bijective. Okay, so but in class 11th, earlier also I explained you that we told that these are the not 1 1 or onto functions. So a function from a to b is bijective, then we know that if you can write it here, if a function from a to b is bijective, then inverse of a function from b to a, inverse of a function from b to a exists such that, now be careful, you can solve it such that why it is means why, how we are getting the inverse. If now how we are writing this one, first comes this function and then this whole the result will be of inverse part. Okay, so f inverse of fx is equal to f inverse f of x is equal to x for all values of, this is the symbol for all values of x where x belongs to a set A. Okay, so this was the basic thing for the inverse part and which we have proved. Now with the help of this one, now we can write it, all these results are direct of this property, that finally we are getting x. Okay, in the other way, if you think that taking this inverse part or composite functions you are getting a little bit bored, I can do it once more for you. Just look at, suppose now if this you are just feeling a little bit boring for this part, we can do it with another part also. Let here we are having theta belongs to, that is the principal value, minus pi by 2 to pi by 2, and this is for what? For I am using the property for now sine inverse. What was the first property? Sine inverse sine theta is equal to theta. I have to prove this one. Now sine inverse sine theta is equal to theta. On the whole, what I explained you up to here for this property, means everything whatever is written here, this will be considered as a true when you are using this result. And what is this result? Let's check it. Now sine inverse sine theta is equal to theta. This I have to prove it. Now theta belongs to minus pi by 2 to pi by 2. Let sine theta is equal to x. Therefore, by definition, for this part, by the definition, what we are getting? Sine inverse x is equal to theta. By the definition we got sine inverse x is equal to theta. Now sine inverse x is equal to theta, and sine inverse x can be written as sine inverse sine theta. Can I write it sine inverse sine theta? Because what this x is? This x is here, it is written x is equal to sine theta. So sine inverse x is equal to sine inverse sine theta. Now from these two, now from this part, one is this one, sine inverse x is equal to theta. One is this one, sine inverse x is equal to this part. So from these two, from 1 and from 2, suppose this is 2, from 1 and 2, from 1 and 2, what we are getting? Sine inverse sine theta is equal to theta. So this we got it. Principal values from minus pi by 2 to pi by 2 for the sine theta, for the sine inverse part, sorry, and when it is invertible. Okay, so by the definition we are having that sine inverse x equal to theta as sine theta is equal to x. So now sine inverse x, in place of this x I put this term sine theta. So sine inverse sine theta is equal to theta. Now this I have proved it now, and it is very much clear, very simple thing for you. Now based on these questions, now as I have proved this sum, we can prove all the 6. You can try for it. All this is simple. In the same thing, in place of sin x, now you have to put a cos x, then tan x, like this one. You can solve it. Now let's move with some nice questions. And remember, you will be getting 1 mark question from these types of questions. Now let's write it. Evaluate question number 1. Now learn this also, and let's do any type of some questions. Some questions I am writing sine inverse sine pi by 4. Suppose this is a first question, sine inverse sine pi by 4. Question number 2, let it be sine inverse sine 2 pi by 3, or better you can write it here like this only, one and the same thing, sine inverse sine 2 pi by 3. Then question number 3, let it be cos inverse cos 7 pi by 3. 7 pi by 3 or 7 pi by 6, you can do anything. 180, okay, let it be, let's take a small angle. Question number 4, now let it should be tan inverse tan 3 pi by 4. Now suppose these are the 4 questions and I have to solve these questions. We will be following for solving these questions these parameters. Now for question number 1, first of all what we have to check it, where this angle falls. Now question number 1, answer for first part. Number 1, sine inverse sine pi by 4 is equal to, now pi by 4 falls where? Pi by 4 falls in between these two, from minus pi by 2 to pi by 2. So according to our first part, sine inverse sine theta is equal to theta, our answer is pi by 4. Okay, sine inverse sine pi by 4 is equal to pi by 4, as you can write it, sine inverse sine theta is equal to theta. This was the reason for the first question, for question number 1, answer 1. Okay, now for the second, this was for the first, so answer for the first is, let me write it here, answers for the first, it is pi by 4. Now sine inverse sine 2 pi by 3, sine inverse sine 2 pi by 3. Now check it, 2 pi by 3 means what? Now in degrees, for sine, minus pi by 2 is minus 90, minus 90 to 90. Okay, so for the 2 pi by 3, can you convert 2 pi by 3 in degrees? Pi is as 180 degrees, so we are getting 2 pi by 3 as 120 degree. So 120 degree doesn't falls in between minus 90 to 90. So what we have to do it? We have to convert it first. Okay. So what basically we can write it? We can write it sine 2 pi by 3, and you can write it if 2 pi by 3 does not belongs to minus pi by 2 comma pi by 2, therefore sine 2 pi by 3 is equal to, now 120 degree, can we convert one to a value of 120 degree in the first quadrant or in the fourth quadrant, from the minus pi by 2 to pi by 2. Okay, can we convert it? Yeah, of course we can check it. Sine pi minus pi by 3. Now when you are taking LCM for this part, pi minus pi by 3, what is left? 2 pi by 3. Okay, now sine pi minus pi by 3 is what? Sine pi by 3. Now you can write it sine pi minus theta is equal to sine theta. Pi minus theta falls in the fourth quadrant. So we are having sine pi by 3. So now what the result becomes? Sine inverse sine pi by 3 is equal to pi by 3. So our answer is pi by 3. For the second part we are having pi by 3. Similarly for the third one now. Best thing is to learn it and then check it, that where our value falls. Now third is 7 pi by 6. Now question 3, it is cos inverse cos 7 pi by 6. Now again 7 pi by 6 means what in degrees? You can, if it is good if you are converting in degrees, because when you are small kids, at from that particular time you are going for the degrees and degrees. Okay, so 7 pi by 6 means what? 210 degree. So 210 degree, and what the result should be? What are the parameters for the principal values? It is in between 0 and 180 degree. 210 crosses the 180, so we have to first change it and see how you can change it. Now here, can I write like this? Cos inverse cos 2 pi minus 5 pi by 6. Is it okay? Because 6 to the 12 minus 5 7 pi by 6, and what is 5 pi by 6 now? 5 pi by 6 is 150. Okay, it is 150. So what our result is now? Cos inverse cos 5 pi by 6, and 2 pi minus 5 pi by 6 is in which quadrant? It will be exactly now 2 pi 1 complete cycle minus 5 pi by 6, or then we are going for the bottom side. Okay, so cos inverse cos 5 pi by 6, our result is 5 pi by 6. So third result is 5 pi by 6. Now coming to the last question. Last question is for tan inverse tan 3 pi by 4. Again check it. Tan inverse tan 3 pi by 4. Now here also 3 pi by 4 does not belongs to. Now for the check for the tan, again it does not belongs to minus pi by 2 to pi by 2. Here be very much careful for this tan part. Okay, little bit from the rest of the 3 questions I have given this question to you, so something is little bit tricky. Neither tricky, you have to just give some tonic to your brain for solving this part, and very easy. So now here 3 pi by 4 doesn't belongs to minus pi by 2 and pi by 2. So what to do it? Tan inverse tan. Now to 3 pi by 4, what can I write? Pi minus pi by 4. Pi minus pi by 4. Pi minus pi by 4 becomes what? 3 pi by 4. Now what is the result for tan pi minus pi by 4? Okay, better is to write tan pi minus theta. What it is? It is minus tan theta. Tan pi minus theta, this is 0, here it is pi. So pi minus theta belongs to this quadrant, and here tan is negative. Okay, so this becomes tan pi minus theta is minus tan theta, and to this part we can write it tan minus theta. Okay, you have already done it, that tan minus x is equal to minus tan x. Okay, only cos minus x and secant minus x, they are positive, they are even functions, and rest are the odd functions. So tan inverse tan pi by 4, pi minus pi by 4. Now what our question becomes? Our question becomes now tan inverse tan minus pi by 4. It becomes tan inverse tan minus pi by 4, and this is the thing, these types of questions are in the examination. So what our result becomes? Our result becomes minus pi by 4. Okay, so tan inverse tan minus pi by 4 is minus pi by 4. So this is the result what we are getting. So for the first part, this pi by 4 was in between our principal values, so this was the result for the first. This we have converted, this we have converted, and this we have converted, and all the 4 were quite easy, and you have to be little bit careful while solving these questions.